Bismillahirrahmanirrahim. My name is Kashif Anwar and I'm here to present my lab tasks. So before I go to the PROTEUS and show the stimulation of all the logic gates, first of all we have to understand what these logic gates are, what are their symbols, their names, and how do they operate. So their operation, we will discuss their operation by their truth table, which will represent their input and output. So there are 7 total digital logic gates we will discuss today, and number 1 is AND gate. Its reciprocal or its opposite gate is NAND gate. Third is OR gate. Its opposite is NOR gate, not OR gate. The fourth is NOT gate. The fifth is exclusive OR gate or XOR gate. The opposite of this XOR gate or exclusive OR gate is exclusive NOT OR gate or XNOR gate. So the truth table of AND gate, it is whenever both the inputs to the gate is 1 or high, we will get a high output. All the other cases will be a low output. What low output means is a 0 in binary. In OR gate, we notice that whenever we have both low signals in input, we get a low signal in output. All other cases where one is high and other is low, or both are high, we get a high output. The third gate is NOT gate. In NOT gate, it's a special condition that we do not have two inputs. We have only one input. Either it is high or it is low. So if the input is low, we get a high in the output. If we have a high in the input, we get a low in the input. Now the one more gate, XOR gate, we will discuss. It is gate when both the inputs are same, we get a low output. So if both the inputs are 0, we get a low in the output. If both are high, we get a low in the output. So if any of the input is low and other is high, we get a high signal in the output. So now we come to the opposite or reciprocal gates of these 3 gates: AND, OR, and XOR. So the opposite of AND is NAND, which means not an AND gate. Okay, so it will the operation will be opposite to that of AND. Whenever we get too high in the input, we get a low, and all other cases where any of the one is high, we can get a high input, a high output, or if both are low, we get a high output. So the next is NOR gate, not OR gate, which means, and in this, if we have two low inputs, low signals in the input, we get a high output in this, high signal in the output. All other cases will give a low output. And the last one is XNOR, not exclusive NOR gate. So in this we see that if we get a same signal in the input, in both A and B, in both the signals, we get a high in the output. all other cases where one is high and one is low, we get a low signal in the output. Now we'll come to PROTEUS and stimulate each gate to see a practical um, a practical stimulation, or we'll confirm the operation that are given in the truth table. So this is a NAND gate, and these are two signals. This is a input signal. These are two signals. The reason we have put resistor in each case is so that the gate gets the signal, and it becomes confirmed that the gate will get a signal from the input. So if we see here, the NAND gate is it gives a low output. It's the LED is off, so it's a low output. So both are off, so this is off. If any one of the gates will be, if we see from here, if both the signals are high, we get a high in the output. So if we click both, it will give a high. If any one of the input is low, it will give a low output. Second is not AND gate or NAND gate. So in this, it will be if both are high, it will be a low. If any one or both will be low, it will give a high signal. Next is OR gate. In OR gate, we see that if both are low, we get a low signal in the output. If anyone or both are high, we get a high signal in the output. Next is NOR gate, XOR gate, exclusive OR gate. So we see that if both are low or if both are high, we get a low signal in the output. If anyone is high and one is low, then it gives a high signal in the output. Opposite to that is XNOR gate. So if both are high or both are low, we get a low signal in the output. If both are high, both are low and both are high, we get a high signal. If anyone is low, then it gives a low signal. Next is NOR gate, not an OR gate. So it will be opposite to OR gate. So we see that both are low, we get a low signal. Anyone is low, we get a low signal, but when both are low, we get a high signal. And one more is NOT gate. So I have refreshed my document, so I will have to make the NOT gate right now before I switch. So as we discussed the operation, if it is low, it gives high. If it is high, it gives low. So it's not working here, but we will have to make a resistor here.